Hey friends, welcome back to the channel. If you're new here, my name is Jeffrey and I'm the CTO for ITQ. And on this personal channel, I create video content around technology in the VMware ecosystem. In this video, we're gonna pick right up where we left off in the previous video, which is we have a nested ESXi environment, 3 ESXi hosts running on top of a physical ESXi server, and we have routing in place thanks to our VIOS appliance. Now in this video, we're going to download, install, and configure vCenter server and do our cluster setup, including vSAN. Without further ado, let's hop over to the Homelab and let's get started. Now, step 1 is of course to download the binaries. Hop over to Customer Connect or Partner Connect and grab that ISO file for vCenter Server Standard. I'm still deploying vSphere 7. vSphere 8 is in initial availability phase right now, but I will leave a pretty nice video to do an in-place upgrade once we're finished with the whole build. So I already downloaded the ISO file. As you can see here, it's a pretty hefty 8.5 gigs. And the vCenter server deployment is done in 2 stages. So it is a client-based installer. So that means from a Linux, Mac or Windows client, you simply start the installer from the mounted ISO file and we start the deployment process there. So in stage 1, we deploy the appliance onto a ESXi server, which in our case will be the physical ESXi server. And stage 2 of the deployment will be setting up the SSO domain, so for single sign-on, and getting the vCenter topology in place. Now, I already started the wizard. Let's choose the install option. Let's click next. Accept the license agreement. Now, this is the target. So I'm going to use the IP address here of my physical ESXi server. Need to provide the credentials. Accept the certificate. And here we can name the environment. So the virtual machine name will be VCO1. I'm going to set my super secret password here. Click next. For a lab environment, a tiny deployment is more than fine. Storage size is also good. So let's click next and select the data store. Now I want to make sure that I'm doing a thin provisioned deployment, and I'm going to install it to my Samsung 960 Pro, which is an NVMe drive. This will give me the best performance. Now I'm going to deploy it on my nested ESXi management network. So this is the network where all my nested ESXi servers are connected to with their VM kernel management port. The FQDN. Now this is a really important step. Please make sure that you have DNS set up correctly for forward lookups and reverse lookups. So homelab.local. Otherwise your stage 2 deployment will fail. It will get stuck at 0% because the stage 2 deployment cannot reach the appliance that you just deployed. So for the IP address, I'm going to do 10.0.10, which is my management network. 100. The ESXi servers, the nested ones, are counting 101, 102, 103. So 100 will make sense. I'm not using the prefix, but I'm using the subnet notation. The default gateway is 254. I need to provide my DNS server, and this is fine. Now, before we click next, let's open the DNS management on my domain controller. Here you will see we have a host record for vCenter.homelab.local with IP 10.0.10.100, and we also have a pointer record for reverse lookups in place, pointing to that same host record. So with DNS all set up properly, let's click next and let's click finish. Now this will kick off stage 1 of the deployment. This will take a few minutes. I'll pause the video right here and we'll pick it up when it's complete. All right, stage 1 of the deployment process is complete. Now let's click continue to kick off stage 2. So click next. Now we want to enable time synchronization. I'm using an NTP server, which is my domain controller. 2.36. And for troubleshooting purposes, especially in the lab environment, I like to enable SSH access. We're creating a new single sign-on domain, so a new SSO domain, and it's best practice to leave it to the default vSphere.local. Put in a password for the administrator at vSphere local account. Now I'm going to disable joining the customer experience improvement program, which is a kind of a diagnostic phone home capability of vSphere. Now here we can look at all the configuration settings, and let's click finish. Now we're going to really kick off stage 2, and then we'll be ready to configure our vCenter topology inside of the vSphere client. So I'm going to pause the video again and pick it up once it's complete. All right, stage 2 has completed. We can now open up the browser and open the vSphere UI. So let's give this a second. It's still using self-signed certificates, of course, so our browser is giving us a warning. It's safe to accept. Now we're going to launch the vSphere client. One of the first things you should probably do is provide some proper license keys. I'm not going to show the steps because that will, of course, give away the license keys that I'm using. These are provided by the vExpert program, which I've been a part of since 2014 or something, and it comes very handy when building a Homelab environment. So check out the vExpert program. It's really awesome to be part of it, and it's a really strong community. Anyways, let's start with configuring the data center and the cluster objects that we need to build our vCenter topology. So let's create the data center objects. So I will name this my nested data center. And I will create a second data center object, which I will call my physical data center, because I also like to add the physical ESXi host to this vCenter server, because it will give features like storage vMotion, which could come in quite handy if I need to move virtual machines between my SSD 850 data store and the SSD 960 data store. So let's open this up and let's build our first cluster. I'm also going to name this nested cluster, just to make it really clear what we're doing. We're going to enable DRS. We're not going to enable HA at this point, because once we enable vSAN, you need to turn off HA before you can enable vSAN. So let's do DRS, finish, and let's create a cluster here as well, just for the sake of it and a bit of consistency. Physical cluster. So DRS, HA, it's not very useful in a single host cluster. So there we go. Now let's edit the settings of the nested cluster. So the default settings for DRS are fine. I'm not going to change any of them. vSphere availability is still disabled. Now I could enable enhanced vMotion compatibility, but given the fact that we're running 3 nested ESXi servers on the same physical box, the chances that we're going to use different CPU families is of course very minimal. So we're not going to enable EVC either. Now it's time to connect our nested ESXi servers to this vCenter server. So we're going to use the fully qualified domain names. Homelab.local. Let's copy paste this. We need to provide the root, password, and username. Let's add the other 2 hosts as well. ESXi02 and 03. We can use the same credentials. Let's click next. All All right, so now the 3 nested hosts will be added and be placed in maintenance mode. Now let's also add our physical ESXi server to the physical cluster. So I'm going to use the IP address there, 192.168.2.35, root, and the password. Oh, I need to check it. Okay. Now first let's fix the NTP and time settings on the 3 ESXi servers. So select the server, go to configure, go to time configuration, and here we can add a NTP service. So our NTP server is our domain controller. Let's add it. Now let's also hop over to services and make sure that our NTP daemon does start and stop together with the host. So on boot up, I want the NTP daemon to be enabled, and when I shut it down, it will be disabled. Let's do the same for the other 2 hosts. NTP. Let's edit the startup policy, start and stop with the host. Hop over to time configuration, add the NTP protocol. Okay. And the final ESXi host. NTP daemon. Okay. Of course, you can do this in a much more efficient way. You can do it using Terraform. You can configure these settings, using a single image to manage your cluster. To be honest, I just have 3 nested ESXi hosts. I'm not going to bother with these advanced settings. Maybe in a future video, I might transition into these more modern ways of managing, but for now, it's just setting up these individual hosts by hand. Now let's hop over to networking. In the current configuration, you will see that if you go to the virtual switches, each ESXi host has a local standard switch, so a vSwitch, which has a single uplink, VMNIC 0. It holds the management port group together with the VM kernel port and an empty virtual machine network port group. Now, at this point, we need to manage these vSwitches individually on each of the 3 servers. One of the key features of vCenter server is the ability to use distributed networking. So we can go over to networking, go to the nested data center, and here we can create a new distributed switch. We will call it VDS01, Virtual Distributed Switch 01. I'm going to select the latest version. We are only using 2 uplinks per ESXi server. I will enable network I/O control. I don't want to create a default port group. Now for vMotion and for vSAN traffic, we would like to use jumbo frames. So let's edit the settings of the virtual switch. MTU size is under advanced. Let's put this at 9000. And we can also disable the Cisco Discovery Protocol. We're not using any of that. Now we go back to the Add a Manage Host wizard, Manage Host Networking. Select all the hosts. I don't want to add the uplink or assign the uplink. And here we can now select the ESXi management port group. And here we can now migrate the VM kernel port. If all goes well, connectivity to the ESXi host will be intact. And we can then finally take the last step, and that is assigning the uplink and kind of switching the uplink from VMNIC 0, which is connected by 3 individual switches, and assign it to uplink 1. This is already migrated. Not going to migrate virtual machine networking. And that's it. We have now successfully migrated from a standard switch into a distributed switch. And we can now add VM kernel adapters for vMotion and for vSAN to all the hosts. Let's click next. I'm going to use for vMotion, I'm going to use the vMotion TCP/IP stack. Something funky going on in my UI. Let's see if I can. Yep, let's click next. I want to use static IP addresses, so that's 10.0.10.0.4.101, 255.255.255.0. I can autofill this and I can autofill this. Yes, let's create a gateway on the TCP/IP stack. And the gateway for the vMotion network is 10.0.4.254. Let's click next. And let's do the same for the vSAN VM kernel adapter. So we're going to add another VM kernel. Click next. The TCP/IP stack is the default one. Let's click next. And we're using the same IP assignment scheme, so 10.0.8.101. 255.0 autofill. Autofill is just a single cluster on the same layer 2 segment, so we don't need a gateway here. All right. So we now have 3 VM kernel adapters on each of the ESXi hosts connected to the distributed switch. So what's now left is to delete the standard switch from each of the ESXi hosts. We can remove it and do the same for ESXi hosts 2 and 3. Now let's hop back over to the distributed switch. And I think we need to do one final thing on each of the port groups, and that is configuring the teaming and failover policies. So let's set everything to route based on physical NIC load. Same for the vMotion. And finally for vSAN, we're going to do the same. Teaming and failover based on physical NIC load. Now the final thing to configure in this video is of course vSAN. Let's go to the nested cluster, select services, and then select configure vSAN. We're going to create a single site cluster in this Homelab topology. I'm not going to use any of the data services such as compression and dedupe or encryption due to performance reasons, of course. So let's click next. Here we can claim the disks. So I have, let's open this up. Here you can see my the 20 gig drives in each of the 3 ESXi servers. They are assigned to the cache tier, and we have 200 gig disks assigned to the capacity tier. So let's claim these disks, click finish. And at this point, vSAN will be enabled and configured on the cluster. So let's give this a couple of minutes and then we'll round up this video. All right, vSAN is configured and enabled. Now let's enable vSphere HA or vSphere availability. So let's go to settings on the cluster, go to availability, edit. We're going to enable vSphere HA. We are going to restart virtual machines when there's a host failure. And because we're only using vSAN, we are going to disable PDL and we're going to disable all paths down APD. We are going to enable virtual machine monitoring for the virtual machines only. And that's it. So now the HA configuration will be done on the cluster. Now let's hop over to admission control. Here I want to disable it. Now in a production environment, you would typically have an N+1 approach or something similar to provide redundancy and high availability in your cluster. In my lab environment, I want to get as much performance out of the 3-node cluster as possible. So I will disable it so all the resources are available for consumption. And that's it for this video. So we've successfully downloaded, deployed and configured vCenter server. We created our cluster, we configured it, we enabled vSAN, DRS, HA. We're now ready to finally install NSX. So stay tuned for the next video. If you like this video, make sure to subscribe to my channel, hit that like button and don't forget to hit the notification button as well. Thank you so much for watching and see you next time.